Okay. All right. So we did the terminal velocity, and now today, uh, let's move forward and okay, yeah. I just want to do one question, which is very very important. Okay. So it says that two markers M1 and M2 are set up a vertical distance h apart. Okay. So they've also shown this. So there's one marker here, M1, and one marker here, M2, and this distance is x, and this distance is h. Okay. Here they've written t1 and t2. Okay. Now it says a steel ball reaches M1 at time t1 and M2 at time t2, right? So it says find the expression of acceleration of free fall. Okay. In terms of T1, T2, and H. So this is the thing. Now, so first of all, whenever there are 2 points which are not starting from, the start, and the same object is falling, so always remember that you take this point, starting point, as reference, okay? Where you should know that initial velocity is 0, because at least something you should know. Okay. Now for this question, there are going to be 2 equations actually. So for the first one, we're going to write SUVAT. So the distance it falls was x, the initial velocity was 0, final is not known. So this is what we're doing is we're doing it for M1. So at M1 we don't know what is the velocity. Acceleration is A, and time is, or you can just write G, and time is T1. Is it clear, everybody?
Yes, sir.
Now just remember that when you do this, right, we'll do it for M2 separately, and just to show you that what I'm actually trying to achieve. For M2, when you do SUVAT, you're going to start with the same reference, which means now the distance or displacement is going to be x plus h, because you want u to be 0. If we take it from m1, I mean t1, that you don't know exactly what was the initial velocity at m1, so that's why we can't, do that. This is not known. Acceleration of free fall is g, and time is t2. Is it clear, everybody? So always take the starting point as reference. Now, when you make the two equations, so the best equation to use would be s equals to ut plus half at squared, because it does not have v in it. So this will be x, this will be 0, this will be half times g t1 square. In this one, it is going to be x plus h equals to 0, because we're following, let me write it so you guys don't get confused. So this will be x plus h, this is going to 0, this will be half, this will be g, and this will be t2 squares, because at this time it reaches that. Is it clear, everybody?
Yes, yes, sir.
Where is Ramin today? Let me check if she's here.
Sir, here.
Oh, Ramin, very good.
I was here yesterday.
Yeah, but you never rejoined the class. Why is that, Ramin? You think I don't know?
I didn't know we had to reach.
You have to rejoin every single time. Okay, x is equal to half g t1 square, and this will be x plus h equals to half g t2 square. Now you see, we can actually replace this x right here with this x, and if I do that, then I'm gonna get half g t1 square plus h equals to half g t2 square. Okay, now I want g. I want g. So what I want to do is I want to take it, the whole equation, to one side. So h will be equal to half g t2 square minus half g t1 square. And then what I want to do is I want to take g as common. So if I take g as common, it is going to be half t2 square minus balki let's take half as common as well. For some reason, I tell you.
So why can't you take half g common?
Yeah, I'm taking that. Half g common, t2 square minus t1 square. Well, it doesn't matter. 2 will multiply there, so it is going to be 2h, and then the whole expression that's here, t2 square minus t1 square, is going to be divided. This will be equal to g, and hence we will get the expression in terms of h t1 t2. Is it clear, everybody?
Yes, sir. Just let me absorb.
Okay. So the thing is that I just want to tell you, people, that always remember to start from the 0 point. Do not get confused, because most of the time they're going to ask you the same question. Okay. All right. And there's a very famous one as well. I just want to point that out before we head on, because a lot of people make mistakes with these sort of questions. So let me show you one question from the past papers, so that you guys wait. This, what is this? Acha. I hope that question is here. Oh yeah, this one. Acha, for this question, by the way, for the reference, you can actually look at, oh no. For the reference, you can actually look at this paper, May June 10, paper 2 question 2. Okay, just if you want to really solve this. So this was the situation, right? Now what they do is they say a student takes a photograph of a steel ball of radius 5 centimeter as it falls from rest. The image of the ball is blurred, as you can see. The image is blurred because the ball is moving while the photograph is being taken, right? Now it says the scale shows distance fallen from rest by this and level with. Calculate to an appropriate number of significant figures the time taken before the photograph is taken. So this is where the photograph had been clicked, and this is where the image appeared, because there is some processing time, okay, or shutter time, what we say. Up, you need to understand that they have given you just a section, which means if I there's one thing that you need to remember. Wait a second, please. The scale shows the distance by rest fallen time top of the ball. Okay, so it says that we will only look at the top of the ball because he has taken the reference as the top of the ball, right? This is what I was looking for. And now from the top, I'm gonna check what is the distance fallen. So right now on the scale, this is like 79 centimeter. Is it clear, everybody?
Yes, sir.
Yes, sir.
So first of all, I will make the equation SUVAT, and I'm gonna start from the point where it had started to fall, which means that the distance it has fallen is 0.79 meters, and the initial velocity would be 0 at that point. The final is not known. The acceleration due to gravity is 9.81, and the time is what we are looking for. Okay, so we're going to use the same equation because this equation will always be used in these sort of questions. So you can automatically see 0.79 equals to 0 plus half. This is 9.81, and this is t squared, that the t we need. Okay, so we're gonna put 0.79 times 2 divided by 9.81 and under root of answer. So basically the time would be 0.40 seconds. So I'm gonna put it here. Okay. Then it says the time interval during which the photograph taken. So basically the image appeared here. It means when the processing had been done, the time had appeared here. Okay, which means that this is 90, and now I have to make another equation. I'm not going to use the same thing, okay? I'm going to use another equation, and I'm going to start from this top again. I'm not going to subtract 79 from 90. In fact, I'm going to take it as 0.90 meters. The initial velocity at the top where it had been released was 0. Final is not known. This is 9.81, and this is the key to these questions, because if you don't do this, then automatically you will be stuck in these questions. Now this will be S equals to UT plus half AT square. This is 0.90. This is going to be 0. This will be half. This will be 9.81, and now we're gonna find T square. Okay, so pull up the calculator, bring it here, and 0.90 times 2 divided by 9.81 and under root of answer. So T would be 0.43. Okay, so I'm gonna write 0.43. Sorry, this is it says time interval, so time interval means T2 minus T1, so it is going to be 0.43 minus, and that's gonna be 0.42, so 0.40, so this will be 0.030 seconds. Is it clear, everybody?
Yes, sir. Yes, sir.
I mean, we
Yes,
could have
sir.
also used the same if we use this expression. This is for G, but I mean, this will also give you the result, but we don't have to do it because that makes things complicated. Anyway,
There's the zero at the end of the answer necessary.
because we need to understand that the data that was given in two significant figures, so we also need to write all the answers in two significant figures. Is it clear? That's the rule I told you. I
Yes.
think I already told you this rule. And especially if he has specifically written that you need to follow the significant rules, like in this question, you have to do it. Okay. Now let's go to.
Sir, but how can you tell it's two significant figures in the
I
question?
can see. Check this out. This is the piece of data he has given. This is two significant, which means these are also two significant figures. Like this 79 is 2, 81 would be 2.
Oh,
Do you understand? So you have to find the minimum one, and then minimum or one more is acceptable. Okay. Now I'm gonna go to the next part, and we're gonna start off with something very, very interesting, and that is rebound. So rebound is basically when something hits and bounces back. So I'm gonna explain this thing. Well, I should use a question, but okay, that's fine. Let me give you a little bit of hint here. Suppose there is a object like this, okay? And this object is from here till here, it is at 1.6 meters. And then they say it lands on a very stiff plate, and then this object bounces back again. So it goes down, and then it bounces back, okay? And it bounces back to a height that is h. Is it clear, everybody?
yes, sir.
Let me make it a dotted line so that you guys don't confuse it with the distances. Okay. Now, just remember there are a couple of things that is happening. There are two different things that are here. First of all, you see this ball had initial velocity as 0, and when it had fallen on the plate, so its direction velocity would be here, and the final velocity is basically, let's call this v. So which means it has fallen 1.6 meters in this direction, and because it is the same direction as g, so we're going to take g in the first section of the question as plus 9.81. I also explained it yesterday. So that's the first section, and the second section was when this ball jumped, like bounced up again, so at a certain height. So here it would have some velocity, and then at the maximum the velocity is always 0, because it has gone through a distance h, and now because the direction velocity is up, as you can see, and g is down, so we're going to take minus 9.81. Is it clear? In conjunction, even if you take g as positive, like before, then you have to take this velocities as negative. Is it clear? So you have to make sure that you take the right thing. Understood?
Yes, sir.
Now what you do is, suppose in the first section they say calculate the speed of ball as it hits the plate. Okay, so we're gonna make our same usual SUV80 thingy, and then we're gonna write, okay, it fell to 1.6 meters, initial velocity was 0, final is what we need to know, acceleration is positive 9.81 meters per second square, and time is not given at all. So the best equation to use would be 2as equals to v square minus u square, because it does not have time. So this will be 9.81, this will be 1.6, this will be v square, and this will be 0 square. So what you're gonna do? You're gonna 2 times 9.81 times 1.6 times 1.6, and then under root of the answer. The velocity would be 5.6 meters per second. Is it clear?
Yes, sir.
Now the next thing is that it says in part B, as the ball falls, as the ball loses contact with the plate, it reaches 40% of the height of the ball when dropped, right? So because some of the energy is lost, that's the main crux of this whole thing. Okay, now calculate number 1, height reached after the bounce. That's pretty simple. What you're going to do, we're going to find 40% of 1.6, which is going to be 0.64 meters, and then it says speed of ball as it leaves the plate after bouncing. Okay. So at this point you should remember that basically we're going to use SUV80 again. This time, now look at the whole thing that's happening here. Everything that was upwards I took as negative, which means this would be minus 0.64 as the displacement, initial velocity is minus u, final velocity is 0, acceleration I'm taking at positive. If you take negative, then everything else would be positive, time is not known. So I'm going to use 2as equals to v square minus u square. This will be 9.81, this will be minus 0.64, this will be 0 square minus u square. Now automatically, if you don't put the right signs, then what will happen is when you take under root, it will give you a math error. But this time, because we've taken the right sign, minus here, and here would cancel out. So then we will have we have no problems. Okay, so 2 times 9.81 times 0.64 and under root of answer, so u would be 3.54 meters per second. Is it clear, everybody? Any questions?
All clear, sir.
Okay, in 9 minutes the meeting is going to close.
Is that displacement or height? S.
Displacement. Displacement is just height, Either.
Yeah.
Okay, so now I just want to draw a graph for this, and well, I haven't told you about the graphs yet. Should I draw it? Should I not draw it? Let me think about it. Um, well, I should draw it with this, but chale, I'll draw it later. Doesn't matter. Rebound's graph. We'll draw it later because I want to still give you some rules. Okay. So before we head on, we just need to basically our vertical motion and the equation of motion, the analytical stuff is done, and now we would like to move towards the graphs. Okay. Now, graphs are super easy in physics. In fact, they're very easy in math as well, as long as you understand the rules behind them, right? And I'm going to show you some rules that you need to remember. And with these rules, you can actually solve or comprehend any graphs that are thrown at you. So the first one is that if there is a line that's like this and it's like going up, a line which is going up in a graph always has a positive gradient. Is it clear, everybody? Now the second rule is, if there is a line that is going down in a graph, this means this has a negative gradient. Okay. Now, in any graph, you will be able to make three sort of tangents. Do you know what is a tangent? Tangent is a line that on a curve that only touches one point. You guys remember this or no? Don't tell me.
Yes,
Yes,
sir.
yes. Yes, sir.
Okay. Generally in math, the gradient is written as m, and how to find gradient is y2 minus y1, x2 minus x1. Some people also do rise over run, but that's also fine. Now, if you see a straight line, I mean a horizontal line, not a straight line. Horizontal line, this means that the gradient of this line is going to be 0 because it does not have any slope. If you see a slanted line and a straight one, it means that the gradient here is constant. If you see a completely vertical line, this means that the gradient here is maximum, or you could call it infinity. Is it clear? Now, without even making gradients, if you see a line of a graph going like this, I mean from a horizontal tangent to a vertical one, immediately you should know that it has an increasing gradient. Is it clear?
Yes, sir.
Yes, sir.
If you see a line that goes from vertical tangent to a horizontal one, this means this sort of line has a decreasing gradient. Now, if you follow these rules, there is no problem with, you will never have any problem with any graph. So I just want you to draw, I want you to write this. And when we're solving the graphs, I want you to follow, okay, what I do. Okay, so the class will end in like 4.5 minutes, and then you guys need to rejoin. Okay. Done. Should I go on now? Okay. Now, the first set of graphs that we're going to deal with are the distance time graphs.
Yes, sir.
Oh, sorry. Displacement time graphs. I'm gonna make some of the graphs. Just give me like a couple of seconds, please. I want to copy this as well. In fact, wait, I'll copy it later. All right. So I'm writing this side is displacement time, displacement time, displacement time, displacement time, displacement time, displacement in time. Okay. All right. Please draw this. And just remember the gradient of this graph, displacement time, gradient is represented by velocity. So whatever the gradient would be tells us about the velocity of the object. Okay, please draw this and then we'll start working on it and the meeting will end. So rejoin and then we'll start this. Okay. Everybody. Sorry. Okay. Now, so what you're going to do is you should understand from the very first thing that in the first section it exactly looks like this line right here, as you can see, which means the gradient is 0. Hence, we would write that the velocity here is 0. Is it clear, everybody? You see? Just look at the rules, okay? You guys can hear me, right? You guys can't hear me? Oh, sorry. You guys can hear me now? Okay. So I'm saying if you look at this line, it is a straight line and it looks like this here. So it means that the gradient is 0. Is it clear? You guys can hear me?
Yes, sir.
Okay, if you look at the next line, it basically is going up like this. It means the velocity is, first of all, it is positive, and it looks like this line, which means this is constant. Understood?
Yes, sir.
This line is going down. It means the velocity here is negative, and it's the same straight slanted line, so it is constant. Any questions? Now, the moment you see this, you should remember that I gotta make one tangent. So I'm gonna make, let's make tangent from green. So from this point, the tangent would look like this, and on this point, the tangent would look like this. The line is going up, so I know that basically it is going from almost a vertical line to a horizontal one, which means velocity is positive, but it is decreasing. Because we learned that when the line goes from vertical to horizontal, it is a decreasing line. Is it clear? Any questions?
No, sir.
Okay, perfect. Okay. Now, then goes this one. You make a tangent first at this point, so it will be like, so you don't have to look at each point, you just need to look at the main points. And because it is going up and it is going from horizontal to vertical, so when it goes from horizontal to vertical, it is increasing gradient, so velocity is positive because the arrow is up and it is increasing. So it is as simple as this if you follow the rules. Now, in this sort of thing, the thing is that there are a couple of things happening. So first of all, at this point, let's, instead of doing it one go, we would like to convert it into 3 parts. So let's call this A, let's call this B, let's call this C. So at A, the tangent is like this, at B, the tangent is like this, at C, the tangent is like this. Okay. So you need to understand that here from A to B, the line is going up, from B to C, line is going down. So from A to B, we can say the velocity is positive and it is decreasing. Oh my god. Wait a second. Positive and decreasing, and from B to C the velocity is negative because it is going down, and it is going from horizontal to vertical, so it is increasing. Any questions? Please look at it. Okay.
So is that it for today?
Yes, it is it for today.